Hello, sir. This is Akila, and this is our topic ROM Introduction and Organization. And these are our teammates Mohana, Akshaya, Maunika, and Ashrita. Memory in digital electronics. First of all, we can see introduction of a ROM. ROM means read-only memory. It is a non-volatile memory, which means the data stored in it does not erase even where the power is switched off. ROM is used to store permanent instructions like the code that helps a computer or mobile phone startup. ROM is very important because it stores programs that should not change and it is used in many devices such as mobiles, computers, calculators. ROM has two main parts: address lines, use it to select a memory location; data lines, use it to output the stored value. Inside ROM, there is an address, decoder, and a memory array. When we give an address, the decoder finds the exact location and the data stored there comes out through the data lines. In simple words, ROM stored fixed data forever and helps devices start and run. Here we can see memory in digital electronics, the foundation of functionality. Memory is a part of an electronic system used to store data and instructions. Without memory, a computer or digital device cannot start, run programs, or remember anything. There are two main types of memory: volatile memory, non volatile memory. Volatile memory. RAM stands for random access memory. Temporary storage loses data when power goes off. Used for processing helps the CPU run applications smoothly. Example, when you open an app, your phone stores all temporary data in RAM. Uses of RAM: running apps and software, temporary data storage, improving speed and performance, and non volatile memory. ROM stands for read only memory. Permanent storage data is not lost even when power is off. Contains important instructions required to start a device. Why ROM is important? Stores a boot program that helps devices like computers, phones, and TV start. Used in embedded systems like washing machines, calculators, microwave, printers. Here we can see key features of unveiling read-only memory. First one is non-modifiable. Data stored once stays permanently, cannot be changed during normal device use. Protects important instructions from being deleted or overwritten. Example, your phone's startup software is stored in ROM so that it always turns on correctly. Next is fixed logic. ROM stored fixed programs that control how a device works, ideal for firmware, system, software, and boot up programs. Example, a washing machine uses ROM to store its wash cycle program. And the last, lookup tables. ROM can store pre-calculated data for last access, useful mathematical tables, conversion tables, and character generations. Example, calculators use ROM to quickly access math operations. Thank you.
Hello, sir. I'm Mohna, and now I'm going to tell about the indispensable role of ROM in digital electronics. ROM plays a critical and multifaceted role in ensuring the stable and predictable operation of digital devices. As non-volatile memory, it stores a permanent data and instruction that a system release on throughout its lifetime. Its reliability, consistency, and secure make it an essential component in almost all digital systems. First one, storing truth tables. ROM is widely using to store truth tables for Boolean functions. By mapping each possible inputs combination to corresponding output, ROM helps implement logic gates and digital functions efficiently. This allows complex logic operation to be handled without requiring additional hardware. And second one is combinational logic. ROM can directly implement combinational logic by storing a predefined output for all input patterns. This reduces the need for multiple discrete logic gates and minimize circuit complexity. Designing digital circuits becomes simpler, faster, and more optimized. Third one is microprogramming. In microprogramming process, ROM is used to store microprogrammers, which are small sequence for micro instructions. These instructions guide the CPU on how to execute mission level instructions. Internally, this makes ROM central to controlling the basic operation of microprogrammer process. And fourth one is error-free data. ROM provides secure and unilateral storage, ensuring the essential data connect by accidentally or changed. This guarantee the integrity of vital information such as firmware and initialization and devices configuration settings. Thank you.
Hi, sir. I'm Monica. Now I will explain evolution of ROM from fixed to flexible. From fixed to flexible, this slide shows how ROM technology has evolved over the years. Starting from memory that was completely fixed during manufacturing to memory that can be now be erased and reprogrammed many times. First one is flash memory. It is also known as modern ROM. Modern ROM and flash memory. The latest stage in the ROM evolution is flash memory. Flash is high-speed, non-volatile memory that supports electrical erasing and reprogramming in blocks. It offers high storage capacity, fast access, and durability, which is why it is used in USB drivers, memory cards, SSDs, smartphones, and modern computers. The next one is EEPROM. It is also known as electrically erasable programmable loop. EEPROM further improved the flexibility because it can be erased and reprogrammed electrically without revealing. The best part is data can be updated byte by byte, so only the required portion is changed. Because of this capability, EEPROM became widely used in embedded systems, microcontrollers, and BIOS. Next one is EPROM. It is also known as erasable reprogrammable ROM. EPROM added a new feature, erasability. It is the storage information needs to be changed. This clip can be erased using strong UV light and then reprogrammed. You can identify EPROM clips because of the small transparent quartz window on top, which allows UV light to pass through it. Next one is PROM. PROM is also known as programmable ROM. Next came PROM, programmable ROM. Unlike masked ROM, ROM can be programmed once by user often manufacturing. Programming is done by blowing internal fuses, but once programming the data becomes permanent and cannot be modified again. Next one is Mastodon, the earliest form. Mastodon is the earliest and latest flexible ROM type. Here the data is permanently retained during manufacturing using months. Once produced, it cannot be changed or reprogrammed. This was useful for mass production and products like calculators or early video game, but lacked adaptability. So the evolution of ROM clearly shows a shift from fixed data to highly reprogrammable storage. The progression reflects the increasing industry demand for flexibility and upgradability in modern digital devices. Thank you.
Hello, sir. I will begin with how Rome is organized internally and how its capacity is defined. A Rome is arranged in a structured manner so data can be stored and retrieved effectively. Its capacity is expressed as n into m. Here, n represents the number of the addressable locations in the Rome. It tells how many unique memory locations we can access using the address lines. Here, m represents the number of the bits stored in each location. This indicates the width of the data that comes out for every slide address. To understand this better, let's look at the example. 1K into 4 ROM. Here 1K means 1024 memory locations because 1K is equals to 2 power 10. Each location stores 4 bits, so the total capacity becomes 1024 into 4, which is 4096 bits. This is clear when n into m structure helps ROM provide systematic and reliable access to stored data. Coming to the next slide, block diagram of ROM. Now, moving on to the block diagram of ROM, a ROM mainly consists of four blocks that work together to output the stored data. The first block is the address lines. These lines carry the input address from the processor and decide which location in the ROM should be accessed. The second block is the address decoder. This decoder receives the address lines and activates exactly one specific row, also called the word line, in the memory array. The third block is memory array, also known as the ROM matrix. This is the actual storage section where data bits are permanently programmed. Each intersection of a row and column forms a bit cell. Here comes the final block. The final block is the output buffer. They take the selected data bits from the memory array and strengthen them before sending them out, ensuring correct and clean output signals. These block structures make ROM faster, stable, and very reliable in delivering stored data. Thank you.
Hello, sir. I'm Akshaya. Now I'm going to speak about anatomy of a ROM cell, how a single bit is stored. A ROM, read-only memory, is built using many tiny memory cells. Each ROM cell stores exactly one bit, either 0 or 1. What makes ROM special is that this stored bit is permanently fixed. Each cell stores one bit. A ROM cell cannot change its value during normal use. If the bit is stored is 0, it stays 0. If the bit stored is 1, it stays 1. The value is decided during manufacturing for mass ROM or during programming for EPROM. And coming to the hardwired logic, how the bit is fixed. Inside a ROM cell, the bit is stored using physical connections. For logic 1, there may be a connection like a transistor path or metal link that allows current to flow. Output becomes 1. For logic 0, there may be no connection or no current path and the output becomes 0. This is why it is called hardwired logic. The pattern of connections itself, it is the data. Coming to the next slide, diverse applications of ROM in digital systems, storing micro instructions. ROM holds the control signals required for executing low level CPU operations. Lookup tables use it to store pre-computed values such as sine, cosine, ASCII codes, etc. for fast access. Sine character generators contains waveform patterns or character bitmaps used in displays and signal generation circuits. Calculator logic. ROM stores fixed arithmetic rules and functional logic used in basic calculators. Encoding or decoding tables converts data between formats, for example, binary to 7-segment display codes. Embedded system firmware stores permanent operating programs for devices like washing machines, microwave ovens, smart TVs, and automotive control systems. Coming to the next slide. Now I'm going to speak up the conclusion of this presentation. ROM continues to be a foundational component in digital electronics due to its permanent, reliable, and non-volatile nature. Its ability to retain data without power makes it ideal for storing critical system instructions and firmware. Built with a structured architecture consisting of address decoders, memory cells, and output buffers, ROM ensures fast and efficient data retrieval. Its widespread use across embedded systems, logic implementation, and essential digital operations highlights its enduring importance in modern electronic design. Thank you, sir.